Hey mathletes, in this video we're going to look at horizontal asymptotes. Now horizontal asymptotes are probably something that you've explored in a previous course, but how you would have looked at them maybe would have been a little bit different. So now we're going to look at horizontal asymptotes from a calculus point of view. So first thing I want you to do is grab that graphing calculator, and I want you to sketch the graph of this thing. So I'll pull up my calculator here just in case you don't have yours. Okay, I've got it in there. And I go and hit graph. Oh, my window settings are a little funky, so I'm going to go zoom standard and try that again. Okay, it looks like this. Now, we definitely see a vertical asymptote, but there's also a horizontal asymptote there. So we want to be able to find that horizontal asymptote. Now, one easy way to find your horizontal asymptote on a TI calculator is simply just to hit the trace button. Sorry, I hit the wrong button there, and just hold it down. And unfortunately on mine, I just have to keep hitting it over and over and over. And you analyze what happens as X gets big. You analyze what happens to your Y values. Okay, and we can see that our Y values on this one look like they're approaching 0. Okay, that's one way to do it graphically. Okay, let's go back to calculus though. So we now know that the graph of this thing looked like this, roughly. Okay, not the same beautiful graph I just had, but it looks something like this, didn't it? There we go. And oh, actually, our vertical asymptote's on the other side of that line, isn't it? So I should get that at least a little better. There we go, like that and like that. And we had a vertical asymptote right there. Okay, so that's what our graph looked like. And this says determine the limit as X goes to infinity of this. Okay, well, just visually looking at that, as X goes to infinity. So as X gets really, really big, the Y values are going towards 0. And in fact, if I asked you to find the limit as X goes to infinity of 1 over 4X plus 3, we would see that again, our Y values, as X gets really, really small in the negative direction, the Y values are approaching 0. What we just did here, my friends, by checking the limit as X goes to positive infinity and as X goes to negative infinity, is how we will determine algebraically the horizontal asymptote. All right, that's the big thing for today. So how do we do this without a picture? Well, we can determine the limit of the following function graphically, but how do we do it without a picture? Well, if you remember back to limits, you did something like this in sequences and series. So what we do is we divide by the highest power that I see in the denominator. So what I'm going to do is I'm going to divide all of my terms by X squared. Oops, minus. Okay, so there's my numerator all over. I do the same thing here, all of my terms by X squared. Okay, and I'm hoping you're saying, oh yeah, I remember doing that. I remember doing that. Okay, and now let's simplify that. What do we get? The limit as X goes to infinity. Well, now in our numerator, we've got 1 minus 4 over X squared, all divided by 3 minus 2 over X plus 1 over X squared. So what happens as X goes to infinity? Well, as X goes to infinity, this term here goes to 0. This term here goes to 0. This term here goes to 0. What do we have left? Simply just 1/3. That is the equation of our horizontal asymptote. So what we're going to do is when we want to find a horizontal asymptote, if we try direct substitution and we get infinity over infinity, what we'll do is what's useful to divide the numerator and denominator by the highest degree that we see in the denominator, and then simplify. And then we do direct substitution, or we just take our limit. Okay, so here's something really important, friends. A horizontal asymptote is what happens as x becomes larger in the positive or negative direction. What I mean by that is a horizontal asymptote doesn't occur around the origin, or doesn't have to occur around the origin. A horizontal asymptote is what happens as we go and get really big in either direction. And then what I need you to remember is when we divide 1 divided by a really, really, really big or small number, right, that's going to give us 0. All right, so a couple of things to think about there for asymptotes. And again, to have a horizontal asymptote, we say it is at y is equal to L if either of the following are true. Notice not both. So as we go to positive infinity or negative infinity, as long as we get a real number, that's our horizontal asymptote. Now, something new for you might be is that horizontal asymptotes can be one-sided or have different values. So again, here you can see on the first example, the horizontal asymptote actually crosses our graph near the origin. And as it goes to the right, the graph has a one-sided horizontal asymptote. Same thing on example 2 or example 3 here. See how many times our graph crosses the horizontal asymptote, but as it gets really big in the positive direction, it'll stop doing that. Okay, so horizontal asymptotes can do some interesting things. And the last example I like is we have a horizontal asymptote going one direction to the left, and we have another one as we go to the right. So the negative and positive infinities give us 2 different asymptotes. So pretty neat, hey? So asymptotes are neat things. So to find a horizontal asymptote, we're going to take 2 limits. This is really important. We're going to check as we go to positive infinity, and we're going to check as we go to negative infinity. All right. And so just a few things to remember. When we divide by a really big number, we get 0. Divide every term in the function by the highest power in the denominator. And if what we end up with does not result in a real number, such as infinity, we do not have a horizontal asymptote. Okay, let's try just 2 of these out. It's not that difficult to figure out. So determine the horizontal asymptotes for the following functions. So the first thing I'm going to do is I'm going to find the limit as x goes to infinity of this, and I'm going to divide everything by that x squared right there. So I'll get 3 minus 1 over x minus 2 over x squared over 5 plus 4 over x plus 1 over x squared. Now as I go to infinity, that will tend to 0, that will tend to 0, that will tend to 0, that will tend to 0. Look at that. 3 over 5. Now, don't stop there. We do it again, but we check as the limit goes to negative infinity. So the limit as x goes to negative infinity, because what we saw in the previous graphs is that it can go to a different value or not even exist. So again, we divide everything by the highest power, and we end up with this. And now as we go to negative infinity, well, that negative infinity doesn't actually change our answer because these will still all just tend to 0. And we end up with 3/5. So our horizontal equation for this graph, the equation of our horizontal asymptote, I should say, that didn't come out right the first time, is 3 over 5. And there it is. Because the limit as we go to negative infinity and the limit as we go to positive infinity is the same. All right, let's try one more. Determine the horizontal asymptote for this one. Okay, so again, first thing I'm going to do is I'm going to find the limit as x goes to infinity, and I'm going to divide everything by x squared. And I'm going to do that in just one step here to save us some time. So 1 over x, 1 minus 1 over x minus 6 over x squared. Okay, now I do my substitution essentially. I figure out, okay, as x goes to infinity, well, that's going to tend to 0. That goes to 0. That goes to 0. So what do we end up with here? Well, we end up with 0 over 1, which my friends tell me is 0. Now, let's check the other side, right? So again, we repeat the process, and we do it for the limit as x goes to negative infinity. So again, we do the exact same thing. We just repeat the procedure, right? Wash, rinse, repeat. And the same thing, my friends, that's going to tend to 0, to 0, to 0. And guess what? This is also equal to 0. So what we can say comfortably is the equation of a horizontal asymptote is equal to 0. Okay, friends, that's horizontal asymptotes and how you algebraically determine them. Next time, we're going to talk about slant or oblique asymptotes. Sounds like fun.